When I first started learning computer science, I already knew how my future would look like. Learn to code, get good grades, and eventually land a high-paying job. But after reaching a certain point, I realized something. My computer science degree was valuable, but it wasn't my career. And let me explain this. Think of your degree like a driving license. A driving license proves you understand the rules, but it doesn't automatically make you a great driver. Computer science works the same way. Your university teaches you important concepts like operating systems, databases, and computer networks. These subjects build a strong foundation and they're important, but companies usually ask a different question. What can you actually build? Can you create a website? Can you make an application? Those are the things employers care about every single day. I've seen students with amazing grades struggle during interviews because they had never built anything outside college assignments. I've also seen students with average grades get hired because they had a portfolio full of personal projects. Your degree opens doors, your skills decide whether those doors stay open. So don't spend your entire college life chasing marks. Spend some of that time building skills that exist outside the classroom, because after graduation, very few people will ask what percentage you scored, but many people will ask what you've built. One of the most common questions beginners ask is, which programming language should I learn? Python? Java? Rust? Here's the truth, you're asking the wrong question. Programming languages are just tools. Imagine someone wants to become a carpenter. Would they become a better carpenter simply by buying 20 different hammers? Of course not. The tool isn't what makes them skilled. Knowing how to solve problems does. Programming works exactly the same way. Many students spend months jumping from one language to another because every week the internet tells them something new is trending. First it's Python, then JavaScript, then Rust, then Go, then another language you've never heard of. Before long, they've learned the basics of 6 languages but can't confidently build a complete project in any of them. Instead of collecting languages, spend time understanding programming itself. Learn how variables work, understand functions, practice writing clean code, understand how programs are structured. Learn how to break a big problem into smaller ones. Once you truly understand programming, learning another language becomes much easier. Most experienced developers can switch languages because they understand the concepts behind them. This is probably the advice I wish someone had repeated to me every week. Start building projects immediately, not after finishing 10 courses, not after watching 50 tutorials. Now. There's a trap almost every beginner falls into. You watch a tutorial, everything makes sense, you feel productive. Then you watch another one and another. Weeks turn into months. One day you decide to build something on your own. You open your code editor and suddenly you don't know where to begin. That's because watching someone else build something isn't the same as building it yourself. Real learning starts when nobody is telling you the next step. Your first project will probably be messy. It might crash. It might have bugs everywhere. That's completely normal. Those mistakes are where the learning happens. Start with something simple, a calculator, a notes app, or a weather app. None of these projects need to be revolutionary. Their purpose isn't to impress recruiters. Their purpose is to teach you. Every project forces you to think differently. You'll search for answers, read documentation, and fix bugs. You'll learn things that no tutorial could ever teach you because you're solving real problems instead of following instructions. The sooner you start building, the faster you'll grow. There's a stupid myth that beginners have. They think experienced programmers remember everything. The reality is very different. Professional developers search online constantly, and the difference isn't that they search less, and the difference is they search better. If your code shows an error message, don't search, "My program is broken." Search the exact error. Include the programming language. Mention the framework you're using. Read multiple answers instead of copying the first solution you see. Learning how to search effectively is an underrated skill. Sometimes you'll spend 20 minutes researching before writing a single line of code. That's completely normal. Programming isn't about memorizing everything. It's about knowing where to find reliable information. The internet is one of the greatest learning resources ever created. When I first heard about Git, I thought it sounded unnecessarily complicated. Commits, branches, repositories, none of it made sense. So I ignored it. A lot of students do. After all, if you're coding alone, saving different versions of your files manually seems easier, until one day you accidentally delete something important or you make changes that completely break your project. Suddenly, you wish you could go back. That's exactly what Git helps with. It's like a time machine for your code. Every important change gets saved. You can experiment without worrying about ruining everything. And once you start working with other developers, Git becomes essential. Almost every software company uses it. Learning Git during college means one less thing you'll have to struggle with later. When people imagine software developers, they often picture someone sitting alone in a dark room writing code all day. Reality is very different. Software development is a team activity. You'll discuss ideas, attend meetings, review other people's code, explain your decisions, ask questions, write documentation, and report bugs. Sometimes you'll spend more time communicating than actually writing code. That's why communication is a technical skill. You don't have to become the loudest person in the room, and you don't have to be an amazing public speaker, but you should learn how to explain your thinking clearly. If someone asks why you solved a problem a certain way, you should be able to answer. If you're stuck, you should know how to ask a good question. Strong communication saves time, prevents misunderstandings, and surprisingly, often separates good developers from great ones.